Modern industrial automation relies on control systems capable of managing processes with precision, flexibility, and reliability. In this context, programmable logic controllers, or PLCs, have become one of the key technologies in automatic control. Since their introduction to replace relay-based systems, PLCs have evolved significantly in processing capability, communications, and versatility, becoming an essential tool for controlling and monitoring industrial processes. To facilitate the practical learning of PLC technology, EDIBON has developed the ALLEN BRADLEY PLC Application, AE-PLC-AB, a unit designed to study PLC-based control systems in a progressive and practical way. The unit follows a modular architecture that allows its capabilities to be expanded through different optional kits and modules, depending on the specific topics to be studied. At the center of this application is the ALLEN BRADLEY PLC base unit, AE-PLC-AB-UB, which integrates the essential elements of a complete PLC system, including the power supply, the PLC CPU module, and the software required for programming. This base unit acts as the core of the system, providing the infrastructure needed to connect additional modules and carry out a wide range of automation practices. Thanks to this modular approach, users can progressively advance toward more complex PLC applications and automation concepts. The PLC installed and programmed by EDIBON provides complete control of the unit, serving as an essential tool in industrial automation learning. Its versatility and control capability are crucial for understanding real industrial environments. The PLC included in this unit offers a wide range of benefits for students and professors alike, being highly configurable and adaptable to various educational needs. Additionally, it provides the opportunity to learn PLC programming, allowing students to view and reproduce the program code directly on the unit. The base unit, AE-PLC-AB-UB, integrates the main elements required to work with a complete PLC system. It includes the power supply module, which provides power to the system and incorporates electrical protections and an emergency stop push button to ensure safe operation. System control is carried out through the CPU module, NCPU-AB, which incorporates an ALLEN BRADLEY controller with digital inputs and outputs, integrated memory, and communication options via Ethernet and USB. In addition, the equipment includes an Ethernet switch module, which enables communication between the different devices of the system, and the test module required for the equipment, which generates digital and analog signals for testing and practical exercises. Thanks to its modular design, the application can be expanded with additional modules to study more advanced automation applications. The AB-PLC-K2 kit includes the ALLEN BRADLEY Analog I/O Module, NASA-AB, which allows users to work with analog signals and study the processing of continuous variables within the PLC. The AB-PLC-K3 kit incorporates the small HMI module, NHMI-BAB, enabling the development of basic human-machine interfaces to visualize variables and control the system through a touchscreen. The AB-PLC-K4 kit integrates the large HMI module, NHMI-AB, which facilitates the development of more advanced monitoring applications thanks to its larger display. Finally, the AB-PLC-K5 kit includes the communication module, NMOD, which allows the PLC to connect to networks or the internet and enables the study of remote control and monitoring applications. The ALLEN BRADLEY PLC Application, AE-PLC-AB, includes a set of practical exercises designed to progressively introduce users to the programming and operation of PLC systems. The first exercises focus on the fundamentals of programming, such as the use of variables, the handling of digital inputs, and the verification of their operation. Students also work on the programming and testing of digital outputs, allowing them to understand how the PLC interacts with different control signals. Subsequent exercises involve the use of analog signals, analyzing how the PLC processes continuous variables within the control program. In addition, users can develop exercises such as the generation of periodic signals, for example using a square wave generator. With the integration of HMI modules, it is also possible to perform exercises related to the design of human-machine interfaces, including data visualization, control of digital outputs from the touchscreen, reading and writing registers, and managing different display screens. Finally, through the communication module, the system allows users to study internet connection and web server-based control applications, enabling the remote monitoring and control of digital and analog inputs and outputs. These exercises help users progressively understand how to design, program, and supervise PLC-based automation systems. All our equipment is completely safe and can have expansions added in the future if you wish to include additional features. Thank you for watching. We hope it has been helpful. See you in the next EDIBON video.